All right, so here are more MCQs on harmonics. Here's the first one. You have a mass and radius of a planet that are double that of Earth. And this is the if the time period of a simple pendulum on Earth is capital T, find the time period on the planet, whatever this planet is. So here are your choices, A, B, C, D, E. So I'm going to go ahead and run this. This is a simple pendulum. So here's Earth, here's a new planet. So the function for a simple pendulum is just 2 pi times radical L for the length of string or cable, whatever it is, divided by the acceleration due to gravity. And then here I'm just going to do the same on the right side, except for, you notice here on the bottom I highlighted G nu. So essentially you're given 2 planets, one being Earth, the other one being some unknown planet. So let's go ahead and crack it out. In order to find T of the new planet, you need to find the acceleration due to gravity on that new planet. So just as a reminder, hopefully by now you understand the function for acceleration due to gravity is just capital G times the mass of the planet divided by the radius of the planet square. And I'm going to do the same on the right side. However, the condition given in the problem is that this mass, the mass of this planet, whatever this planet is twice the mass of Earth. So instead of writing m, I'm just going to multiply that by 2. And then the radius of this planet is also double that of Earth. So in parentheses, I'm going to go ahead and write 2r. So it's important that you use parentheses here. Otherwise, you'll goof on the distribution, the exponent 2 on the bottom. Okay, so use parentheses. So if you do this correctly, I'm just going to move all the coefficients out in the front. The 2 in the numerator is just pull out to the top or left there. And then the 2 square, again, the exponent goes to the 2 on the bottom. It also goes to the r. So 2 square is 4, so that's where the 4 comes from. And then r square is on the bottom there. So you can clean this up. 2 over 4 is just 1/2. So instead of saying 2 over 4, I'm just going to say it's 1 over 2. But now that I have that, I can rewrite this acceleration due to gravity in terms of Earth's gravitational. So watch when I'm boxing up. The stuff that's in blue, capital G m over r squared, that is just the acceleration due to gravity on the surface of the planet Earth. So instead of saying big G times m divided by 2r squared, I can simplify that down to just G, acceleration due to gravity on Earth, divided by 2. So I'm just going to plug it in. So where G nu is highlighted in the function on the right, instead of saying G nu, I can replace G nu with what I just calculated, which is G divided by 2. Here you have L divided by a fraction. So anytime you divide by a fraction, you would just multiply by the reciprocal. So this is what it looks like. So you can say it's 2 times capital L divided by G underneath the radical sign. So I can see here, there's a radical 2 here. So really, all you have to do is focus on the radical, the 2 on that's underneath the radical. So in this particular case, if you factor everything out correctly, you have this extra radical 2. So the answer here would just be C. Okay. All right, let's move on to the next one. Here you're given a displacement versus time graph, and it asks you which of the following statement is correct at t over 4. So I'm just going to say this is t half, this is t over 4. So make sure you understand the graph given to you. The whole period is given. Half of that be, again, well, half is t over 2, and then half of t over 2 is just t over 4. So you asked to find the true statement. I'm just going to go ahead and draw a tangent line. This is a displacement versus time graph. So that tangent line there is my velocity, my instantaneous velocity. So the slope or the tangent of a peak or valley is just flat, so it's just 0. So at this point at t over 4, you can say that the instantaneous velocity is equal to 0 because the tangent line is 0. So just based off of that, I can cross out choice A because it says v is greater than 0. I can cross out B because B says v is greater than 0. It needs to be 0. I'm also going to cross out choice E because those are all false statements based on just analyzing the tangent line of a displacement time graph. I'm going to keep C and D because they both have v is equal to 0 as the first option. So I need to figure out what my A is. Okay. Well, to figure out my A is, this is pretty light work. It says here that at times equal to 0, the object is initially at equilibrium, so it's already moving. And then at t equals 4, the object is at maximum positive amplitude because at t equals 4, you go up and then you go left. This A that I'm circling back and forth, that is on the right side of the equilibrium. So if you watch this particular animation, on the right side, as you can see, A is always changing, okay? But on the right side, when I'll just wait till it comes out one more time. At this moment right there, you see A points to the left. If A points to the left, that would imply that it's negative. So I'm just going to go ahead and pick choice C because it matches with both conditions that I need. V has to come to a stop because it's at maximum amplitude. And at maximum amplitude, that's on the right side. The spring force has to pull left. And if the spring force pulls left, then A also points leftward. It always points towards the equilibrium. All right, let's move on to the next one. So here you have an object on a spring and harmonics, and it's just that the amplitude of oscillation is double. How does this affect the oscillation period and the object's maximum speed? So in this particular case, you're doubling up the amplitude and you're asked to compare T for period and Vmax. So hopefully this is a mass spring system. So you know that the period for a mass spring system is just 2 pi radical m over k. At this point, if you can just look at the function itself, it does not depend on the amplitude. Okay, so this is kind of a trap setup for you. So as you practice, analyze functions, see what is dependent of or dependent of. So the period for a mass spring system does not depend on the amplitude. So even if you quadruple it, triple it, half it, it doesn't matter. Changing the amplitude does not change the period. So therefore, I'm gonna go ahead and cross out choice A. Choice A said that T is double. I know that it cannot change. Choice D, it says T doubles. I'm gonna cross that out, the whole thing, just because the first part is already wrong. And then I'm also gonna cross out choice C. Choice B says T remains the same and V remains, or V doubles. C here says T and V max both remains the same. I'm gonna cross out C. Why T does remain the same? When you stretch an object farther out, it'll shoot back faster just because there's more stored energy in the spring. So why the first part of choice C is right, just using common sense, Vmax cannot remain the same. Okay, that's kind of why. So I'm going to cross out choice C. So therefore, I'm left with B and E. So I'm going to go ahead and figure out which it is, B or E. All right. So the second part of this condition is Vmax. Well, the Vmax function is just the amplitude times the angular frequency. But if you know, you know. If you don't, hopefully you can derive this. The angular frequency is just the square root of K over M. So as you can see here, both these expressions, regardless how you break it down, has the amplitude involved. So here I made a statement for you. Vmax does depend on the amplitude. And again, I think that's just an intuition thing. If you pull like a rubber band farther out and you let it go, it snaps back faster. If you play with the Nerf gun, if you cock the Nerf gun back a little farther, the Nerf bullet will shoot out faster. So those are just things that I think can help you visualize based on just common sense deduction here. All right. But if you like the physics statement here, Vmax has an A in it, so therefore I'm just going to follow its lead. It says double the amplitude, so instead of A, I'm just going to say I'm going to double up the A. So A here, inside the parentheses, there's a 2 in front of the A. Other than that, as you can see, A times omega is just the original Vmax, and then the 2 gets carried down, so I can just say that the V max here is just twice. Or you can really just look at it from the beginning. Vmax equals A omega. This is a linear function, so if A goes up by 2, then Vmax goes up by 2. Okay, so that's that for this one. So I'm just going to go ahead and highlight choice B. T remains the same, but Vmax doubles. Okay, and this graph I provide on the bottom here just to help you visualize. You have a blue and a black graph. Both these have different amplitudes. As you can see, from 0 you go up to A, and then at 0 you go up to B. But however, both of these intersects the t-axis here at the same time, suggesting that it is possible for a mass block system to have different amplitude, right? Same mass, same K, but different amplitude, like you stretch it twice as far. Because you stretch it twice as far, it has more distance to cover. However, stretching it twice as far will also change the acceleration. So the increase in acceleration will help compensate for the time. So it actually ends up crossing the same point at the same time. Because it accelerates a little quicker given that it has more distance to travel. All right, so let's go and move on to the next one. This one says to double the total energy of a mass spring system, the amplitude must increase by a factor of. So this one's pretty light, so I'm just going to start with E total. So you go to 1/2 Ka squared. I'm going to start with this function because the total energy in the system is either Ke max or Pe max. I'm going to choose to go with Pe max here because it's 1/2 Ka squared because the question involves amplitude. So instead of saying E total equals 1/2 Ka squared, the problem says that you're going to double it. So instead of saying E total, I'm just going to put a 2 in the front. Okay. And then E total, we already know from the left side. E total is just 1/2 Ka squared. So on the right side, you notice here the 1/2 stays, the K stay, because this question changes the amplitude, not the K. So here I just have the new amplitude squared. So I'm just going to go ahead and substitute out E total for 1/2 KA squared. On the left side, we have a claim that says E total is equal to 1/2 KA squared. So instead of E total, I'm just going to replace it with the true statement. So the 1/2 and the K cancels out because it appears on both sides. So here, there's a 1/2 times K. On the right side, there's also a 1/2 times K. So I'm going to both cross out the 1/2 and the K at the same time. On the left side, all you have left is 2 and A squared. And on the right side, the only thing you have left is A nu square. So to find A nu, you would just do the square root of both sides, just to get rid of the exponent 2. So therefore, the square root of 2 is just radical 2. And then the square root of A squared is just A. And then the square root of A nu square is just A nu. So as you can see here, this particular answer matches with choice, let's see, D. Okay, so you're looking for a radical 2. All right, this is the increase. So you do have to stretch it a little bit more. All right. This one is the last one of this particular video. So here you're given a y of t function, and it says which choices closely describes the amplitude and frequency, linear frequency here of the motion. Well, let's just look at the graph. You're given a y of t in centimeters, and then this is the time in the horizontal direction, or in the horizontal plane here in all units of pi. All right. So just by looking at the graph, I'm just going to identify a couple of things here for you. I know that the distance from the t-axis all the way up to the peak, that's called the amplitude. While the amplitude is not necessarily 2, I think the problem says closely. So I'm just going to go ahead and call this positive A. And then I also know that the time from peak to peak, or from maximum positive A all the way back to maximum positive A, that's called a period. And the period in this case is just 16 pi because the graph said so. Okay, so all the time here is 8 pi, 16 pi. So if you go to one period, you go all the way down. The period here is just 16 pi seconds. So just based on that information, I can cross out a few things. B is whack because just the amplitude is 4. No, the amplitude is only 2 because you have to measure it from the t-axis up or the t-axis down. I'm also going to cross out D and E. So I'm left with here choice A or C. However, if you know your physics function, the frequency is 1 over period. So here the period is identified already as 16 pi. Right, so from the graph, you can quickly pull out that the period is 16 pi because that completes one revolution, one cycle. So it'd be 1 over 16 pi. So here, frequency is 1 over 16 pi. So right away, we can go ahead and let's cross out C because C says F is equal to 16 pi. No, it's 1 over 16, which matches choice A. All right, that's it for this one. Stay nerdy, don't be wired.